Now let's go through question C. An object when placed at a distance of 15 cm from a convex lens forms a real image which is twice the size of the object. First question, determine the focal length of the lens. So before we go through our questions, let's list down our information. So the information given here is the object distance, which is 15 cm from the lens, and also the magnification of the image, which is twice the size of the object. And this is a convex lens, and it forms a real image. So listing down our information, u is equals to 15 cm, and our magnification is equals to -2. So, why is the magnification for real image is a -2? This is because if we use the magnification equation, capital M equals to the ratio of the image distance over the object distance, and there's a minus in front. Let's say we have the image distance, and this is a real image, so it will be a positive value to be 12 cm, and the u to be 6 cm. So if we plug in our numbers, we get the magnification to be a -2. The magnification not only shows, the magnification here shows that the image form is upright. The magnification here shows that the image form is inverted. Well, let's say if we have, this is real image, and let's say if we have a virtual image, so the value for the image distance will be negative, and the u is same, 6 cm, and the image distance for this one, this is a virtual image, minus 12 cm. The value that we get when we plug in our numbers is a +2, showing that the image form is upright. So remember that for lens, such as this one, if the image is formed the same side image form same side as the object, it is virtual. And if the image form opposite side as the object, it is real. So now let's continue to answer our question, but let me rub off a few things first, and then we continue to answer our question. Okay, question 1. He wants us to find the focal length. We're going to use two different formulas, which is the magnification equals to minus image distance v over object distance u, and also the lens equation, which is 1 over f equals to 1 over u plus 1 over v. So this is our first equation, this is our second equation. So now we can plug in our numbers. We write that back down. Plug in our numbers on to the first equation and we will get rearrange to get V. So that's our third equation. Now we can sub equation 3 into equation 2. Now we can rearrange. You either rearrange to get F or you can plug in your numbers, then you can rearrange. Since the object distance here is given, which is positive 15 centimeter, we can plug in that number and get the value of F, which is positive 10 centimeter. That is for question 1. What about question 2? Question 2 states that where must the object be placed so that a virtual image which is also twice the size of the object is formed? So we have to find the value of U where the image form is going to be virtual. So over here, it also says that the image form is still twice the size of the object form. So let's write down our information, which is the magnification is positive 2, like I said just now. If we have U equals to positive value, V equals to negative value because it's a virtual image. And we know that virtual image is going to be upright because if we insert it again into the magnification equation, this one, you're going to get a positive value and it shows that the image form is upright. M here is equals to positive value, upright position. Okay, now let's answer the question. So again, we're going to use two different equations, which is the magnification. First question, the lens equation. Second equation. Sub in our value. Sub in our values. Rearrange to get V. This is our third equation. Sub in our third equation into our second equation. Now we can sub in the object distance. So we want to find the object distance, right? The F is what we got just now. It's just positive 10. So U as it is. Rearrange for U and we will get positive 5 centimeter. So this is where the object must be placed for a virtual image to be formed, a virtual and upright image to be formed. Right, since we have answered C, now let's go through D.